Here we go, jumping on into chapter 3, where we are dealing with the applications of the derivatives. So now that you know how to take derivatives, what can we do with them? Let's check it out. The first thing that we can do with a derivative is we can find what are called extrema, or you might have already heard of them in class as maxima and minima, or a maximum and a minimum. Let's talk about them. So what is a maximum and what is a minimum? Basically here, informally speaking, if you've got a function's graph, right, and it's on an interval, and we have that right here. So we're going to go over what the absolute max and min are shortly, but just in general, you got any interval. The highest point on that interval, the highest y value, is your maximum. The lowest value, the lowest y value, or the least value, is your minimum. That's it. We call those absolute minimum and absolute maximum. That's all. Formally, if you got any interval such that f of k is a minimum, then that's going to be true if f of k, the y value, is less than or equal to f of x for all x values. Basically, that means that it's the lowest point out of all the y values. And f of k is a maximum only if f of k, the y value that we have, is more than or equal to all other y values, f of x, for all the x values in that interval. Okay, so that's very formal. But let's take a look at it. I think the graph will make this very simple. We are instructed to circle the absolute extrema, the absolute maximum and the absolute minimum, on the graph over the interval negative 2.5 to 2. If you don't like that notation, that's the same as negative 2.5 is less than or equal to x is less than or equal to 2. So negative 2.5 is roughly here, roughly, right? Not exactly. And then what we've got here is we're looking for the y value between here, which is x equals 2, and all the way down to negative 2.5, such that it is the highest y value and the lowest. So I'm going to abbreviate that, the absolute minimum. What will that be? Well, so far we're at roughly negative 5. That's not the exact value, but roughly negative 5, just by looking at the graph. So we're approximating it. And we just kind of travel on the curve and notice, though this value right here is at its highest point, that doesn't make it a minimum, right? We're looking for the lowest point for the minimum. Well, this point, no, there's still no points lower than that starting one. That point is pretty low. I mean, it's the lowest point in this little neighborhood here, but it's still not the absolute lowest. And we end our interval at x equals 2. So the absolute extrema is going to happen here at x equals negative 2.5. And it's approximately, so the min itself, so the minimum is the y value, is approximately negative 5. You could find it by plugging in negative 2.5 into this. It's not the exact answer, but approximate. And that's what we're going for here, just conceptual understanding. Okay, let's now go into the absolute maximum. All right, well, what's the absolute maximum? The absolute maximum is the highest point on this interval between negative 2.5 and 2. So again, we go from negative 2.5. All these points are higher than the start. We're still going up. Ooh, this is a good candidate. It's pretty high. Are there any other points between this x value and that one in this window such that we are higher than that point? And the answer is no. That's the highest y value in the interval. So that's going to happen at x equals, and I have it here, negative 1.155. That might not even be the exact answer, but it's close. It's a good estimate. And the max itself is always the y value. It's approximately 3.079. That's it. I just wanted you to be able to locate them graphically. All right, let's keep going from here. We're going to keep this real simple. So the maximum is the highest y value, the minimum, the absolute minimum, the lowest y value. All right, let's keep going. Where are the only two places where an absolute maximum or a minimum occur? Well, let's take a look back at the graph. Again, our maximum was here, and our minimum was here. So the only two places that you should ever check for your absolute max or min are the endpoints, and we'll go over why that makes sense, and the hills and valleys, right? So that's not at all formal. We'll give a formal definition of what these hills and valleys are shortly. These are known as relative maxima and relative minima, essentially the top of a hill and the bottom of a valley, right? That's what you're looking for. So I'll just write that in there, the top of hills and the bottom of valleys. That's it. And why does this make sense? Well, let's think about it. If you start out really, really low and you increase your y values everywhere, even if you decrease everywhere after, and then you increase again and you never quite dip down below this value, then that starting point ended up being your absolute minimum. Now, you could have had a minimum here had this hill dip down, let's say, below, like down there. Or that valley, I should say, dip down below there. Then that would have been your absolute minimum. So we look at the bottoms of valleys, we look at the endpoints, and we look at the tops of hills. Now notice that we had an absolute maximum occur at the top of a hill, right? What is known as a relative maximum. Again, more on that in a little bit. That's because we increased everywhere before it, and we decreased after it, and then even though we increased a bit more to the other endpoint, we never quite increased enough to account for the decrease that we lost here. So this ended up being the highest y value. There's no point in checking for absolute maxes or mins here or here, in between the endpoints or the hill and valley, because you're on your way to a hill or on your way to a valley. So none of those points on the way to any of these values or the endpoints could be the highest or lowest. So the question here becomes, what if there was a hole at one of the extrema? Okay, so what if instead I took this point and we had a hole there? What if I defined the function and said, you know what, we're not going to include that endpoint? The answer would be then we would not have an absolute minimum. We could approach what that y value is, but you never actually approach a set value, right? You keep getting closer and closer to approximately -5, but never actually get there. So we wouldn't have an absolute min, we'd still have an absolute max. So if your teacher does something like that, where they take out a point where there otherwise would be an absolute max or a min, we now no longer have an absolute maximum or a minimum value. It's kind of interesting. Okay, from here comes this very simple theorem that some professors and teachers get all excited about. Don't know why. I call it the no-duh theorem. Formally, it's called the extreme value theorem. If a function is continuous on a closed interval, okay, that just means don't pick up your pencil, and we've got endpoints that are filled in, then it must have an absolute minimum and an absolute maximum. All right, yeah, so what this is basically saying is, if you draw a curve, like any curve, like that, a continuous curve, and you put endpoints on it, you're going to have a highest point and a lowest point automatically, even if it's a horizontal line. You'd have a tie for a whole bunch of absolute minima and maxima. That's all the extreme value theorem is. Don't put in too much attention to that. It just guarantees that any continuous closed interval has a highest value and a lowest. Okay, cool. All right, last but certainly not least, we're going to go over identifying what are now known as relative, or sometimes some teachers refer to them as local, maxima and minima. The singular would be a maximum and a minimum. All right, so we're just going to do that by simply looking at the graphs. Identify the relative maximum or minimum on each graph below. Okay, here's x cubed minus 4x. We saw that graph in the previous problem. A relative maximum is the top of a valley. Sorry, the top of a hill, basically. So that would be here. It's the top of the hill. Boom. That would be a relative maximum. To be more formal, relative to all the points around it, it is the highest value. And endpoint, right? An endpoint is not a local maximum or minimum. You must be at the top of a hill or bottom of a valley. So this would be the relative minimum right here. We're at a bottom of a valley right here. Simple as that. On the graph of y equals minus cosine x below, we've got a few relative maximum. Top of a hill is right here. Another top of the hill. Both of those are relative maxima or local maxima. And this would be the bottom of a valley, making it a relative minimum or local minimum. Notice that all the points around the relative maxima are not as high as that. And all the points around the relative minimum are not quite as high. You can have multiple relative maximum, and a relative maximum can be an absolute maximum. Here was a relative maximum, and it was the absolute maximum on an interval. This was a relative minimum that just happened not to be an absolute minimum. This is a relative minimum that also happens to be the lowest point everywhere. And so it's also an absolute minimum. Finally, we've got just one relative maximum right here. It's the highest point in this neighborhood right here, and it also happens to be an absolute maximum. It can be both, but it doesn't have to be. Last but not least, you're asked the question, what do you notice about the derivatives of the graphs where relative extrema occur, where a relative max or min occurs? Well, let's take a look at them. The slope of the tangent line here is 0. And here as well. And here as well. So we've got lots of slopes of tangent lines at the relative maxima and minima that are 0. And here, the derivative does not exist. So I'll just call it f prime. Either f prime is equal to 0 or does not exist, right? Is undefined or indeterminate. That's it. And that makes sense because you've got to change from a positive slope to a negative slope, or a negative slope to a positive slope to cause that turning around effect to happen, right? Here's a positive to a negative slope. More on that in a little bit later section. All right, so that's one heck of an introduction into visually what absolute maximum and an absolute minimum look like, as well as what a relative maximum and a relative minimum look like. They're very simple. Keep it easy visually. We'll get into the calculus of it soon. Peace.